Hello, this video is a recap on using QGIS, some of the basics for loading in data. I'm going to show a couple different ways of loading the data, how to check some of the settings for both shapefiles and raster file, and we're also going to look as a reminder of projections and datums, because they're very important up front to make sure that they match. And I don't even know with these test data here if they do match. I'm going to use the data we were using before for the Corvallis area, and I also downloaded a high resolution elevation data, or DEM, digital elevation model. That's what DEM stands for, and that may not match. So if so, we'll even correct that using the tools for changing the projection datum. If you've never used QGIS but you have it installed on Windows, you can search, find QGIS here, or if you go in, you should be able to find it in your downloads. So here I have QGIS 3. It's launching on my other screen, but here in a sec it should pop up. Here we go. So by default, it looks like this, and we talked quite a bit about projections and datums. So down in this lower right corner, we have this EPSG 4326. I'm going to click on that, and this pops up. So this, again, as a reminder, this is the projection datum setup, or often referred to as the CRS, Coordinate Reference System, which is just a concept of pulling together the projection and the datum together as one idea. And this is really important that your projects and your data all match. As a reminder, for visual purposes, QGIS or ArcPro will do this thing called project on the fly, where it'll make things look correct. But as soon as you start to get into a lot of the tools that directly manipulate the data, or trying to run anything with like spatial statistics, things like that, where basically there's just direct interaction between the spatial data, various types of math going on, then that's where you run into problems where things start to not work correctly. So here we have, this one's a pretty typical WGS 84, which is a setup for the full world geodetic system, and it may stay like this or it may not. Different types of software, when you load in your first shapefile or raster layer, quite often this changes, but just pointing this out now, we have WGS 84 as a beginning. Up there in the top corner, I'm just going to select a new project. Here, I don't know if we really talked about these in the class, but you can set up, if you have certain setups, certain mapping exercises you're doing a lot, you can create templates, and then your various templates would be right here. By default, you just get this basic one. That's the WGS 84, nothing crazy about it. Selecting a new one, I'm going to get rid of that. So we have our table of contents over here, or layers. Our data frame is this working area. And there's two ways to add data. Just to get some data on the map, I'm going to show the way I usually do it. So here I have some data to work with. As a reminder, on this end, you must extract your data. Whoops, went too far back. So this data originally came as this zipped data, and then I extracted all of these files, and when I did that, I put them into this folder called raw. And so here are those layers, with the exception of these elevation data, which I just added. For good clean project management, I should probably actually cut this and move it over into my zipped, so all my zipped files are together. There we go. So then these are just for backup, and you shouldn't be working with any compressed or zipped data. It should be uncompressed or extracted, same thing, and that's what all of these data are. And so I'm going to start with, let's see if we could pick a boundary layer. I don't know if any really matter. Well, we'll just go with the boundary, see what this is. I don't know what this is, assuming maybe it's the city boundary. As a reminder, we talked a lot about vector data and raster data. Vector data has this format where the spatial data itself is in this SHP file, and some of these files are mandatory, like the I believe it's the DBX and the database file. So you have to have these three files for a shapefile to function. But these other ones are secondary or like associated files that can be very helpful. Many of these, as you do certain things with your data, get automatically created for you. Quite often this PRJ file, even though it's optional, it's actually extremely useful file. It's what's defining your coordinate reference system for the data. And if you want to do drag and drop, which is what I prefer to do, then you want to find for vector data, find the SHP file, and you're just going to click and drag it over. I'm getting a warning because, again, the coordinate reference system was WGS84, and it looks like it already changed. So it's just telling me, hey, these didn't match, and so just giving a warning that it is changing them. So now if we look at this EPSG in the corner, we are now using NAD83, Oregon North in feet, and which is appropriate for Northern Oregon. So not surprising that the Corvallis group would be doing that. Looks like we have this, I don't know what this outer boundary is, that doesn't look like the county. And then the zoomed in area here is Corvallis, to parts of it at least. We could kind of investigate what these different areas are. But this video, maybe we'll do that in the next video, but this one's just about loading in some data so we can look at it and check the coordinate reference system. And so the other way you can add data, we'll add some more vector data. If you don't want to do the drag and drop, or if you're not sure which layer to add, you can go to layer, add vector layer for vector data, add raster for raster data. These really just take you to the same place though, so if you click the wrong one, it's not a big deal. Because you're like, oh, I meant to add some elevation data. Well then, you can just switch it to raster. This is pretty normal GUI setup for QGIS. Here we need to add, this is where we would add our vector data, and the file or folder explorer is these little three dots. A lot of software has an actual little folder or something like that, but in all the GUI settings or tools and all that in QGIS, it's these three little dots. So you want to watch for those. And let's see, that is not. I'm gonna change this directory to where it's working. There we go. So let's go back in boundary. Maybe we'll look at fire districts. So again, in QGIS, you still have to realize which file to click on. So for vector data, it's always that SHP file. With raster data, I have one example here, but it's you're going to want it to be normally, well, it's the file that has the data itself, the actual spatial data. It's always that file. So for that would be like a TIF or TIFF. Sometimes you see it as GeoTIFF, or ASCII files, ASC, IMG, or image files. There's a whole bunch of different formats for raster data. And so now that I've selected my fire district, hit add, and close. There we go. So now I have my boundary layer, whatever that is. At least part of the boundary layer is the city of Corvallis. And then the fire districts that don't quite match up, a little bit different. So it'll be interesting to, in the next video, we'll explore the attribute table and playing around with the data. We will though look here is the properties, because this is place you go just all the time in QGIS for any layer you're working with. the layer you want to look at the properties, in the layers window, you would right click and then go down to properties. And this is where pretty much all the action is for any layer. If you want to change the way things look, that would be the symbology. If you want to look at the CRS that's assigned, then this is where it would be. They have a warning here that changing this does not change what the layer's coordinate reference system is. And then they inform you that you need to use the reproject layer tool if you need to actually change what it is. And then under information, this is really useful for vector data to just, there's a couple different storage formats, but you don't really change anything here. And vector data is just, it's just points that are connected together, or nodes, I guess. Nodes connected together by lines, unless it's a point file, and then it's just a bunch of points. So there's some useful information here regarding what's in the file, but the most useful thing here is probably just where it is, the path, full path directory. It's also useful to know coordinate reference system, but again, you can get that here from the source. Raster data, there's a lot more in here that people always want to know or work with. I guess one thing that is really important is what are your units, and then this is directly tied to the datum that's part of the coordinate reference system. And so let's add some raster data. So I'm going to do that by going to layer, add raster layer versus vector. Takes us pretty much the same place though. Again, browse using the three little dots. And I'm going to go back one folder into this elevation. So raster data comes in often tiled form. So when I selected for the Corvallis area, the area that I defined, let me see if I can show. Do I still have that up? Sorry, one sec here. I don't. Never mind. But I selected the Corvallis area from the USDA Data Gateway website, and for rasters, it turned out it required two files of data to cover that whole area. So that's this first one, NED, National Elevation Data, 3 meter, and then this is the number for the tile. And then you'll see one of them is E3 and the other one is E2. So that'll make more sense here in a second once I add them. Again, we have so we do have a difference because these ones came in UTM. There we go. So you can see visually what's going on here is that there's this division here between the two tiles, and I can turn one off, turn the other one off. So this is how the data came to cover the whole Corvallis area. And apparently my bounding box, I just covered the majority of Corvallis, but it looks like I may have even missed just a little bit. So to fully cover Corvallis, looks like we might need 2 more tiles up here, 1 more here. That would kind of create a funny shape though. So you might actually want to get both of these southern tiles and end up with 6 total. But for exercise here, this is fine. When you have 2 different tiles like this, you immediately run into some common GIS data sets or steps that you need to work through. Really, the reason that these look so different is because their data ranges are quite different. One goes from 50, I can see up here under the layers, one goes from 53 meters to 587 meters versus my other layer, this one that we see a lot of detail. The data range is much tighter, so 55, so very close on the lower end, but the max is only 110. And so the grayscale color ramp there's just a lot more, because the data range is a little tighter, there's just a lot more available color space for representing all the different data types. versus it's really being stretched out a long ways here from 53 to 587 on this left side. So we lose a lot of little detail. So to fix this though, if you need to work with this together, two things should happen here. We need to merge these two layers together into one continuous seamless layer. And since it will only be one layer, that will solve the data range problem. And then the other issue, just for I guess brevity, is you want to also reproject that final layer to match the project's coordinate reference system, since there's a mismatch. Let's go look at the properties for the raster. Don't know why that popped up on my other screen. That was interesting. So here it's instead of the Oregon North, we have UTM Zone 10 North. UTM is Universal Transverse Mercator. It is NAD 83, so we're working on the same datum, but we're working under a different projection setup. So we would need to use the warp reproject tool. Rasters have their warp tool, and Vector Data has the Vector Data has the reproject tool. They both do the same thing, but they're just different tools because it's different types of data. But the end goal is the same for both tool sets. So. Also under here, though, while we're looking at this, for information under raster, there's a lot more here versus vector data. We still have our units, we still have our coordinate reference system, also useful for the full path of where exactly this data is. You end up getting a lot of data sets, 20, 30, 50, all in one project. Then, you know, trying to keep track of where everything is can become a little tricky. So this is very useful to be like, okay, this is this one versus this other layer I'm trying to work out. You can, you know, go off, figure out where that layer exists. Things you don't get with the vector data, but you do with raster, is the width, the number of columns of the data, because it's all just a gridded space. The height, so the number of rows in the data type itself, so this is a floating point precision in this example here. The data type, GeoTIFF, again, versus maybe an image file versus a ASCII file, or some of the many other, NASA has like their bill and their PIL and formats and a bunch of others. So then the rest of this stuff's useful, but not stuff you look at too much. But the one that is important here is the pixel size or resolution. So this is 3 by 3, so 3 meter resolution. So, cool. So let's merge these. To run that, the merge tool, any tool for rasters will be under the drop-down raster. And I always have to look around and find it. There we go. Under miscellaneous, we have merge. So this pops up here. You just fill it out with any of these types of tools. So I'm selecting my inputs. You would normally have all the different raster layers available, but in my project here, it's really simple right now. It's the two that I want to merge are the only ones here. So I select those two, hit OK. The output data type you can change, but I want it to be float because the input data is float. By default, it's just going to select whatever the input data is. You can run into issues with this though when maybe you're merging two different data sets that one is in integer and one is in float. So then you might want to define what the output type you want. And there's some other more advanced settings here, but none of them we really need for this exercise. You can certainly look through them. And this is a kind of a quirky thing with QGIS is if I just put like a file name here, then it's going to crash because it doesn't know where to put it, meaning like the folder system on your computer. And so the easiest way to do this, well, actually I should say by default, some of the tools will just run and create a temporary file, which is very useful if you're not sure it's going to work or you're playing with a lot of these advanced settings and you don't want to permanently save the results. So that can be useful. It'll just give it a generic name, probably merge, because it's the merge tool. But if you know you need to save this, you want to go to the drop-down menu, go to Save to File, I did that again. Eventually it starts remembering where you're working. So in here with my elevation file, I'm going to call this the, I don't know, just merge dim. I often like to put the resolution on the dim in the name, especially if I'm working with a lot of different ones. I'm going to change this to TIFF. That's the very top option. TIFF, GeoTIFF. And now it's all filled out, just hit run. There we go, ran it, hit finished. Just close the tool. And now you can see, again, we had these two tiled sections, but if I turn those off, then turn on my merged result. Now, I lost a lot of the detail here. We could go into the symbology settings and play around with that to reveal a lot of that detail again. But I don't have that seam in the middle because now this is just one continuous data layer. One problem is that around the edge, there was a little bit of a boundary issue. And so it ended up where there's no data, it ended up putting in 0, which in the symbology settings, we could ignore these areas and that would help a little bit. And then there's a whole bunch of other settings you can play with the symbology. Pretty quickly, if you go to like a pseudo color versus the default grayscale, in here you always have to hit classify, at least in QGIS. I think ArcPro is opposite. I'll use spectral because I know it's going to come out pretty vibrant. Well, because I selected a color ramp, it automatically classified in that case. That still didn't really help. It really highlighted the foothills to the west of Corvallis, but we're still not seeing all that detail. But there's a lot of ways you could play around the symbology and make that better. So. But lastly, though, we still have that problem. This is a classic. This whole video here is all the classic initial issues with data. We have that UTM problem because it's not in the Oregon North setup. And so to fix that, we can go to raster. Where is the warp? There we go. So under raster projections, warp, or reproject in the parentheses there. This tool here, by default, it put in the layer that I had selected already in the layers, but if that's the wrong one, you can change it. And by default, the option is just going to take whatever the coordinate reference system is for the layer. But target, you're going to need to tell it. And so you're going to have a little drop down here. This first one here is what our project is, and that's also what the vector data is. And so that we're going to change it to that data. And then there's a bunch of advanced settings that you usually don't have to worry about. Again, they're the typical things of your spatial extent, or if you want to force a different data type output versus the default. Again, maybe I want to force it to be integer, but in this case I don't. I'm just going to let it be float. And again, towards the bottom here, you navigate to where the file is. Now it remembers where we're working. So it's still that merged dim data, but we're just going to have a different coordinate reference system. And if the reference system has an EPSG code, I like to just put those in. So I can say EPSG, because I can always go look up what those are. If they don't, or you want to do it a different way, like, instead of putting this, you could type out like Oregon State Plane North, NAT 83 or something like that. Makes the file names much longer, which is why I like using these short little codes when they're available. They're not always available, but. Then we hit run. And there we go. So now I have two layers that look similar, this one and this one, but this one here in this grayscale is much more appropriate for my project, because if I go into the settings, we'll now see now it is NAT 83 Oregon North and feet. So it matches my vector data. And at this point in a project, I would probably, so I prevent confusion, I would click on these ones I no longer need. and just remove them from my project. Not deleting them, they still exist in my folder system. I'm just removing them from the project. So that's the initial QGIS, getting it launched, loading in vector and raster data, which is 99% of all data we work with. How to check some of the properties and where to look for the coordinate reference system, and a couple tools and running them to correct data. With vector data, you might clip the data down, which maybe we'll do in the next video, but you normally don't have to, you never have to go through those issues of, oh, I got these different tiles. Like, vector data doesn't come in a tiled format. It's just raster data that you have to initially do that to. There are ways of merging more advanced tools of blending together different vector data sets, but by default, you're not going to receive vector data like that. But very common for raster data to come in tiles because it's just, it's very memory bloated, these raster layers, especially the high resolution ones. So very common you have to merge those together. And very common with all data that you have to correct the coordinate reference system. Thanks.